Good morning, good afternoon, or good evening, depending on where you are in the world. And thank you for joining this learning experience brought to you by Synopsys. My name is Cody, and welcome back to Techstrong Learning. Before we dive into things, I have just a couple of housekeeping notes to review with everyone. First of all, we are recording our session today. So if you miss any of our conversation, if you'd like to watch again later, or of course, if you'd like to share this with the rest of your team, we will be sure to send the on-demand recording over to you via email as soon as we conclude our session today. Now, if you'd like to get involved, there are a couple of ways to do so. Your first option is to use the chat tab on the right side of your screen. And when you find that chat tab, I'd like you to let us know from where in the world you're joining from today. Now, for specific questions, we want you to submit those using the Q&A tab on the right side of that chat section. We'll be doing our best to address as many of your questions toward the end of our program, so setting those into the Q&A just helps us keep track. Additionally, if you jump to the handouts section, you'll see there are a couple of additional resources there for you, so feel free to grab those while you're here with us today. And we will have a poll launched here in about a minute toward the front end of our program, so keep your eyes out for that as soon as it pops up. My final note is that we will be selecting 2 of our most engaged attendees to win a $50 Amazon gift card. So ways to become eligible are to send in your chats, send in questions, and of course to fill out our post-webinar survey, but attached both in the handouts, and I'll post it in the chat toward the end of our session. So today's topic is the evolution of Shift Everywhere. And I'm joined today by Chai Bat, Security Solutions Manager at Synopsys. Chai, thank you so much for joining me today on Techstrong Learning. I'm going to pass it on over to you now.
Thank you, Cody. I appreciate being here, and thanks for having me. So today, as Cody said, we're talking about the evolution of Shift Everywhere. And we have a quick poll, so we'd really appreciate it if you can attend it for basically answer the poll for us, and it'll show up on the right. And it's just a simple yes or no poll about, have you heard of Shift Everywhere or not? So it's a relatively new term, so I wanted to kind of get a pulse of if you guys have heard about it or not, and I would appreciate it if you guys answer that one. So let's get started. Here's the agenda for today. So I'll start with, this presentation is primarily derived from 3 pieces of research. So we'll start talking about those. Then we'll talk a little bit about the timeline of evolution for just security testing within organizations, and especially in the software development lifecycle. Then we'll talk about Shift Everywhere. We'll dig deeper into it. What does Shift Everywhere mean? How did it come to being? And how it has evolved in the past. And after that, we'll talk about where it's going in the future as well a little bit. And then finally, what we'll do is we'll kind of end with some software security best practices that are that leading mature software security organizations are doing to kind of deal with this Shift Everywhere phenomena. So let me see if, okay, so a lot of you have not heard of Shift Everywhere. So I can tell you basically Shift Everywhere is the methodology where you are doing security testing across the software development lifecycle. So as soon as an artifact is available that you can test on, you're doing the testing on it ASAP. So you're doing it as often and as frequently as possible across the software development lifecycle. So, an artifact that could be a piece of code, it could be an infrastructure for testing, it could be a container image, it could be an API, it could be a variety of things, right? So as soon as it's available, you're testing it at the right depth and at the right breadth, and basically automating it as much as possible as well in the SDLC. So that's kind of Shift Everywhere. Since you guys not heard about it, I'll give you a quick brief overview of it, and then we'll dig into it a lot deeper in the third section as well. So as I mentioned, this research that I'm presenting today is derived from really 3 pieces of Synopsys research, right? So we've been doing the first one, BSIM, which is Building Security in Maturity Model, for I think the last 17 years or so. And bulk of this data comes from the BSIM. So the data that I'll be showing you comes from the BSIM report. So BSIM essentially is, if you're an organization that's doing software security or application security, and you want to measure what you're doing, and you want to compare what you're doing to what your peers are doing in the industry, and you want to kind of see, okay, we're doing these activities, is that enough? Or are we doing enough for software security? And if not, what are my peers in the industry doing, and what I could be doing to improve my program? So you could kind of measure your software security program maturity by using the BSIM model. It's an open framework, so it's kind of open source. Anyone can go use it. And basically, we do about a couple of hundred BSIM studies every year, and we publish a report, I think about November or December every year, that publishes this data. The other piece of research that I'll be deriving from is the software vulnerability snapshot report. So that, again, we do a lot of testing. We do thousands and thousands of application security tests, managed services tests every year. And we look for vulnerabilities that are available in production applications and in the SDLC, and we kind of publish that report. So I'll be deriving some of the data from that as well. And the third piece of research is the open source security and risk analysis report, the OSRA. So we do publish that every year as well, and that's more focused on open source security and supply chain security and so on. So a little bit of some of the data that you'll see here is from that as well. So let's talk a little bit about the timeline of evolution of application security testing, and not just application security testing, but security testing. So when I first started doing product development, and it was a long ago, it was in the mid-90s, and when I was doing it, there was almost little to no security testing at all in the software development lifecycle, right? Then I think around the year 2000 or so, what happened was people started realizing that security is important, and then they started doing some form of security testing, but that was in the QA area, right? So it was in the testing area. You were still not doing anything in the SDLC. And that was typically done after an app was constructed. So you had a fully functional running application. You would do the QA testing in the security testing in the QA area. Around 2005 is when people realized that, hey, maybe it's a little too late to be doing security testing in QA, because if you find vulnerabilities, you find defects, you find flaws that late in the SDLC, and as you guys probably already know, it takes a lot more effort to fix them. It costs a lot of money, and it takes a lot of time to turn back and fix the flaws, the bugs that matter. Right, so the shift left phenomena kind of started in 2005, and it evolved over the next 15 years. And then in 2020-ish, I would say where the BSIM report first learned and discovered about shift left evolving into shift everywhere. So BSIM 11, I think it was, that first dug up the methodology of shift everywhere in the SDLC. So, the studies that they did that year in 2020, a lot of organizations were already starting to use shift everywhere. And since then, over the last 4 years or so, shift everywhere has evolved significantly. So, and I'll talk about that, where now it has evolved to kind of doing security testing, not just in the SDLC and everywhere in the SDLC, but even doing security testing past the SDLC. So now let's dig a little bit deeper into shift everywhere. I kind of give you a high-level overview of what it was. Now let's dig a little bit deeper into what shift everywhere, specifically shift everywhere within the SDLC means. As I said before, initially we started by doing testing in quality assurance, right? So after an app was built, typically it was pen testing that was done, right? So you hired a group of experts, either external experts, or you had the team within your organization to do pen testing, and they would find what security defects there are, and they would try to fix. They would make a list of here's the high priority ones, here's the mid-level priority ones, and here's the low-level priority ones, and the developers had to fix them according to the priority level assigned by your business risk and your unique application risk and so on. So that was, as I said, it was a bit too late. So what started happening is it, security testing started shifting left more. So in 2005, basically they started doing static analysis on a working code. They started doing software composition analysis on working code, right? And this was done in the build phase of the SDLC. So, and that's where the shift left phenomena really started. And then after static analysis and SCA in the build phase, they started moving even more left in the SDLC to the coding phase of the SDLC. So when the developers were actually writing the code, you had IDE integration with static analysis and with software composition analysis. So almost like a spell checker, right? As you're writing the code, the scanning is identifying the defects and highlighting them for developers to fix. So the sooner you find them, the faster you fix them, the cheaper it is, and you can enhance your production and your application security that way. So we started moving but left to the coding phase, but that was not left enough, right? So they moved even left to the planning phase. So and here, especially in the planning phase, they started looking at your application's architecture, right? So there was one study done by IEEE, I think it was 5 years ago, that showed that almost 50% of your defects in your application are actually design flaws, right? So if you're doing any kind of automated testing like SAST, SCA, DAST, you're never going to find a design flaw, because that's just inherently a flaw in the design of your application. So that can only be detected by doing architecture analysis, right? And then you're also looking at your attack surface. You're looking at the security controls you have in place to prevent attacks and so on. And that's done in threat modeling. So these activities like architecture analysis, threat modeling, setting the right security requirements, functional and non-functional security requirements, making sure you had the appropriate security controls in place to stop attacks, that started happening in the planning phase of the SDLC. So that was the furthest left that you could shift. So after you shifted from pen testing to doing SAST and SCA in the build phase, and then doing threat modeling and architecture analysis in the planning phase, they shifted right again. So in the last 3 years or so, they determined that, okay, but is that enough? You're just testing the working code. But what about the binaries, right? So you have to test the binaries as well. So they started doing SCA against code repos in the test phase. Again, you're testing the binaries using SCA. It's a different type of SCA, but you're still doing it. Then you finally had a functional application. Then you're doing actually dynamic analysis on the fully functional application. That's the earliest you can test an application, when it's fully assembled and functional, right? So that's the earliest you can test a running application, by doing binary SCA, by doing dynamic analysis. So you started doing that again by shifting right in the testing phase. And then they determined, okay, so as security has evolved to keep up with development and DevOps and so on, the other thing has evolved is how you're actually deploying the application, where you're deploying the application, right? So you're using containers a lot. You're using microservices a lot. You're deploying the application in the public, the private, or in hybrid cloud a lot, right? So the infrastructure that you're deploying has changed. You're using a lot of APIs more, because there are more microservices in play now. So there's a lot of APIs for communication. So you have to also check your infrastructure, right? You have to check your cloud, if your cloud is configured correctly for security. You have to scan your container images for security. You have to do API testing. So that started being done in the release phase of the SDLC as you move to a different infrastructure and different implementation methods. So after that, then they determined that, hey, no matter how much automated testing we do, we still cannot find hard to find defects, right? So if you have defects such as broken access controls for some reason, right? So if you have a broken access control, uh, uh, or if it's not working correctly as it should, or if it's not even turned on, and no amount of application testing you do in the SDLC is going to find that. So you need actually some level of manual testing. You know, you need bug bounty or red teaming, or penetration testing to find those kind of hard to find defects, right? And so you came back to doing pen testing right before you deployed the application into production to ensure that these defects that could not be found by automated testing within the SDLC are found and fixed, right? Prioritized and fixed. So, and then the other thing you wanted to check for is drift monitoring. So, you know, you set your requirements, you set your controls, but in the actual production app, is there any drift from what you had set in the planning stage of the SDLC? So you want to check for that as well before you deploy the app. And even after you deploy the app in production, you want to keep regularly monitoring your application and checking for drift monitoring. You also want to do continuous dynamic analysis in production. Make sure that if there's any changes to the application, if there's any changes to the attack surface, the new techniques that are being used by AI to kind of take advantage of vulnerabilities and compromise them. So you have to do dynamic analysis regularly after the application is in production to make sure that you're always safe and protected. So that's kind of what Shift Everywhere it was, right? You're not just doing testing just as far left as possible, but you're doing it all across the software lifecycle, not just the software development lifecycle, but the software lifecycle. That includes infrastructure, that includes APIs, that includes containers, and you're making it very context specific, and you're doing it at the right time, and you're automating it as much as possible to match the DevOps methodology that's used by your development teams, right? So let's move ahead and talk about Shiftware Everywhere, but specifically within the SDLC, right? So, and traditionally what happened was waterfall security. You had one big gate at the end of the SDLC, right? And that's testing right before you deploy the app in production. And that was just too slow. It was too late, too little, too late, and it was too slow. So if you had to fix anything, it was very expensive to do it at that point in time. So as development evolved from going from waterfall to agile and to finally the DevOps era, right? So you had to keep up with the agility, the fast and the frequent deployment of applications. The evolution of software was just so fast that security had to evolve with it, and they had to start integrating security tools, application security tools, especially into the developer keychain, tool chain, and make sure that you have much smaller contextual checkpoints all across the SDLC, right? Not just one big one at the end, but smaller, more contextual checkpoints all across the SDLC that are automated and that make sure that you have the right policies in place. And if you're failing one of the policies, you send it back to make sure that the defect, the vulnerability gets fixed appropriately, and then it passes the checkpoint and moves on. So that's what really Shift Everywhere is. It's integrating and automating testing, application security testing across the SDLC with smaller checkpoints and making sure that your application is as tight as possible before it goes into production. So now, I mentioned beyond the SDLC, right? So as I say, because of APIs, because of containers, because of cloud, you have to almost do testing beyond the SDLC as well. So that changes what your software security group has done, has been doing for about 20 years. In the past, software security was a lot easier, right? Typically, software security would deal with developers, with your compliance department, quality assurance to a certain level, right? So everything you see in the green boxes there, that's who software security worked with traditionally, and it was very easy, and not as many departments, very easy to work with. And as again, as development evolved, as from waterfall to agile to DevOps, and as the infrastructure evolved, as there was new microservices, containers, APIs, zero trust came into being. So that changed a lot. And a lot of tech companies were hiring site reliability engineers to make sure that their website and their external facing application was reliable and functional and secure. So as these new uh, infrastructures, these new development methodologies evolved, software security had to keep up, but they also had to work with a wide variety of people that they've never worked with before, right? And if you consider like your average software security department being 6 to a dozen people max, it was no way that they could scale to so many different people in so many different departments and work with all of them without finding a way to kind of do some knowledge transfer to those individual departments. And what they started doing after that to making sure that they picked a security champion in each one of these groups. They trained them on security and enabled them to be the security expert within development, within operations, within the infrastructure team, within the site reliability team, and so on. So that way, you're actually empowering, training, and enabling, and almost expanding the role of software security to other groups without having to add on additional security engineers, by training everyone, right? So that's what's going on now, is to keep up with Shift Everywhere. The role of security champions has gotten a lot more important for these days. And as software and as infrastructures gets more and more complex, software security is really the thread that connects everyone to everything, right? So software is at the heart of everything. So you have to make sure that it's secure and safe. And the best way to do that has been through the role of security champions. And we've been seeing that in BSIM for the last 5 years or so, that software security teams have expanded beyond their traditional role by training people in other departments. So Shift Everywhere also goes to basically the software supply chain, right? So again, in the last 6 years or so, we saw gradually that vendor management in BSIM has gone up significantly. So basically they started out, hey, where are you getting your software from? Which vendors are you using? Do these vendors that you're using, are they trustworthy? Do they have the right security requirements? Are these baked into the contracts that you're have with these vendors to ensure that these security requirements are in place before you inherit that software from them? So vendor management has significantly increased over the last 5-6 years, and we saw that the policies, security policies that the vendors have to ensure compatibility with it has gone up 56%. Communication standards with vendors that supply you software have gone up 46%. So just within the last year in BSIM. So vendor management is really become very important, especially in the last 2 years. And that is for good reason, right? So that is because of increasing supply chain attacks. And as you guys have heard, probably President Biden a couple of years ago signed an executive order to make sure that if you are a vendor or an OEM, a software OEM that's supplying software to the federal government, you have to maintain certain standards, and your software has to be at a certain level of security defect free to make sure that it's being employed in government applications and so on. So that's partially what's led to this increase in vendor management. And again, open source is on the rise as well, right? So coupled with vendor management, software that you're getting from third parties, there's also open source libraries that you're getting software from. And I think there was a research done a few years ago that says almost in most enterprise software a decade ago had very little, maybe 10% open source. But now enterprise software is over 90% of it is open source software. So again, identifying what software, open source software you have in your application and managing the risk that comes from open source software has gone up significantly in the last 5-6 years, but especially in the last couple of years. So, it's almost like a two-pronged effort, right? You're managing vendors that supply you software, but you're also managing the risk that comes from the open source that you rely upon to build your application. And as I mentioned, a couple of years ago, the EO, the executive order, was introduced by President Biden, right? So essentially, the executive order maintains that if you're a supplier to the federal government, you have to generate a SBOM, which is a software bill of materials. It's almost like, here's all the ingredients that are in my software, and here's all the vulnerabilities, all the flaws, all the defects that currently exist. And I would say even not go beyond that, right? Here's my plan to fix these vulnerabilities and these defects before I deploy the software. So the SBOM has become extremely important. And because of that, 2 years ago, we saw a new BSIM activity being kind of employed by software security programs. And this activity was perform application composition analysis on code repositories. And then we had another new activity, basically, that was specifically related to software supply chain risk management, right? So they're kind of integrating vendor management, having an SBOM, making sure your open source risk management is managed properly. All three of these are integrated in a greater SSCRM, Software Supply Chain Risk Management Program, by a lot of the software security groups. And they, because of that, these two new activities of generating an creating a bill of materials, making sure that you have the as you run SC on your code repositories, and you have a good, solid software supply chain risk management program in place, has come up a lot in BSIM in the last couple of years, and I imagine it'll keep growing as well. So now, we talked a little bit about what we have been seeing and how in the last decade or so within software security, and how Shift Everywhere has evolved to going from security testing after the application is built in the QA phase, to shifting left and then shifting right again, and then shifting beyond the SDLC to your cloud infrastructure, containers, APIs, microservices, and so on. So now, what does that all mean? What does that do to software security best practices, right? So coupled with this, the other thing we're seeing is a lot of companies. So Enterprise Research Group is a research group that's they did a survey, I think it was a couple of years ago, and they found that over 70% of the organizations that they surveyed were using over 10 application security tools in their SDLC. And that's just application security tools, right? So what about other security tools, like, tools for scanning containers, tools for checking your cloud configuration? So those could be half a dozen or a dozen more of those. So a lot of companies have a variety of security tools in place within and outside of their SDLC to kind of keep up with shifting everywhere, right? And that introduces a lot of complexity into your security, and not just your security scanning, but the process that you use to make sure that your policies are correct and they're uniformly deployed across all tools. Make sure that there's no duplicate vulnerabilities being found. What about false positives? One tool could detect a vulnerability and the other would not. One would the way say one, if you have a SaaS tool, right, it can find a vulnerability and it could say it's a critical vulnerability. But then the SCA could hypothetically find the same vulnerability, and it could say it's a low-level very low risk vulnerability. So your policies could be different across tools. So there's a lot of complexity that goes in. So what are companies doing to manage this complexity that's being introduced by Shift Everywhere, right? So we kind of dig into that here a little bit. So one of the things we see a lot of companies are doing is they're consolidating their application security tools. They're consolidating their vendors, and they're trying to simplify by consolidating. And they're essentially consolidating in a three-step process. The first step is being consolidating the effort, right? The effort that's put into your security program. So by that, they're using, a ASPM tool, application security process management tool, to centralize policy. Instead of having 10 different policies and 10 different tools, they're having one central policy within an ASPM tool that kind of, set it once and you forget it. It enforces it at scale across all your tools, so it's consistent and reliable, right? And then there are automated testing across the SDLC. So, and that's partly to keep up with DevOps as well. So, your testing that you do, the depth that you do the testing at, and the time you do the testing at is all automated. The policies are enforced, and they're at the right checkpoints. So make sure that, hey, if you don't pass a certain checkpoint, you don't go ahead. You stop, you fix the critical defect, and only then can you go ahead. And the third thing they're doing in terms of effort consolidation is you're integrating as much as the tooling into the existing development environment, right? So no developer, no DevOps engineer wants to go outside of their existing environment to do anything. They're familiar and they're happy with where they reside, and they want to do as much as possible within their existing environment. So that's the third thing that leading software security companies are doing, is that they're actually integrating application security into existing development environments. And the second, as I mentioned briefly, is they're consolidating the vendors and tools, right? And that's simplifying everything quite a bit, right? So you're removing duplicative functionality. You're lowering false positives by using tools that are market tested and reliable and have been around for a long time. And that helps a lot, because if you have 1,000 false positives, that's a lot of time for development and security to spend triaging a bunch of false positives that are not even real, right? So it's valuable time spent in the DevOps era. So that's just not acceptable in DevOps. So the less false positive you have, the less duplicate vulnerabilities and defects you find is very, very important, especially in the DevOps era, right? So you're improving resource efficiency as well, because you have less people that are dedicated to consolidating findings and defects and vulnerabilities and bugs from dozens of disparate tooling, right? Because you have one centralized report that that's deduplicated and shows you all of your vulnerabilities, and they're ranked in, you have X number of critical, X number of low-level vulnerabilities, and so on. And that's what an ASPM tool essentially does, right? So you're kind of orchestrating almost all of your application security testing tool, its policies, its reporting with one ASPM tool, right? So that's what a leading software security groups are doing now, is they're using ASPM to kind of consolidate all their application security testing. And the third thing is consolidating insight. Again, deriving insight from dozens of disparate tools is also extremely hard, right? Because they all have their own policies. They all have their different scales for reporting defects. They all have prioritized findings differently across different tools, and there's they all generate their own report, and it can be confusing. So if I'm a director for application security or software security, and if my CISO calls me and tells me, hey, I have a board meeting today and I need one source of truth, is here's all the defects I have today in my software, and here's my plan to fix them. How are you going to do that if you have a dozen different tools, right? So again, using ASPM to kind of normalize, aggregate, and prioritize findings across tools and provide one source of truth for one picture of risk really helps when you're communicating your risk posture to, even within the company, to your executives, to your board, or even for compliance, right? So, a lot of times, if you're in an industry that requires you to have compliance with your industry regulations, you have to actually present to them a report, your risk report, almost yearly, or sometimes even bi-yearly, right? And this having an ASPM tool that's centralized really helps with that. So a lot of companies are using ASPM to consolidate their application security and to simplify it significantly. The other problem has been that you have a ton of disparate tools. You're doing a lot of testing across the SDLC and even beyond the SDLC, right? In addition to that, what's happening is that there's much more larger applications that are being built and deployed, right? For example, this was like 9 years ago already. So they did a study and they found that your average luxury car that rolls off the assembly line in Detroit or in Germany has 100 million lines of code. So that's a lot of lines of code. And, you compare that with a F-35 fighter jet, which has only 8 million lines of code, right? So software is really, really expanding its role beyond traditional applications and going into areas that have a lot of really, really large applications, right? So, or distributed applications, distributed software rather, when it comes to IoT. So it's not just the size of the software that's increasing, but there's the number of applications that are being used and deployed is going up as well. So again, this survey was done by MuleSoft in Detroit a couple of years ago, Deloitte rather, sorry. And they found that your average company uses about 976 discrete applications at any given time. A lot of these could be public facing, a lot of them could be internal applications, some of them could be partner facing, but that's a lot of applications to test. So the scale that you need to test application security at is constantly going up. And if you have to scan many lines of code, it takes time. And the more time it takes, it's disrupting your DevOps methodology of deploying as fast and as frequently as possible. And it's introducing unnecessary friction. So you need to make sure that your application security tools can automate and integrate into your existing SDLC without disrupting dev velocity, and scan at scale without lowering the speed of development as well. So it's extremely important to make sure that you have the right application security tools for scaling, not just across millions of lines of code, but also across many apps as well within the enterprise. So that's the second thing that companies are doing, is they're making sure their application security is built for scale. And the third thing they're doing is, again, I kind of touched on this earlier. So, given that we're coming up on time, I won't spend too much time on it, but visibility is extremely important, right? So what was tested? What was found? What was fixed? What's my plan to fix my most critical defects? What's my plan to fix my mid-range defects, and so on? So you need a plan to communicate it. Ask for resources, ask for budget. You need a lot of times you have to communicate your security posture, your risk posture with partners, industry regulators, and so on. So it's extremely important to have a single version of truth for software risk, right? And an ASPM really helps with that. So having a centralized tool that kind of aggregates all the results and shows you one integrated report for everything really helps with it. It reduces the complexity. It consistently uniformly applies policies across different tools. It produces actionable results that you can act upon. It actually prioritizes defects centrally. And there's one level of priority, not like 10 different levels of priority. And it really helps you consolidate everything: your testing, your reporting, and your risk management into one thing. And in this economic environment where interest rates are up and funds are hard to come by, a lot of companies are using consolidation and ASPM to consolidate other application security tool to reduce your total cost of ownership for application security as well. So that's a third thing that we're seeing in good mature software security programs. And in summary, in the shift everywhere era, right? You're doing a lot more testing across many applications and many large applications. And because of that, you're introducing a lot of complexity in not just your SDLC, but your infrastructure and your containers and so on. And so to really keep up with security testing these days, it's important to consolidate, to scale your AppSec program, and to ensure that you have visibility into your risk posture at any given point in time, right? So those are the three things that are really in top of mind for leading software security programs these days, and everyone's focused on these. So I urge you to look at your software security and your security in general from this lens, and see how you can improve your program as well. And I think that's all I had. So be happy to take any questions.
All right, he said the magic word. Chai's requesting questions, so everyone go ahead and send those in. We're going to take the ones that we've received so far from the top. So this one I'm actually going to put up on screen. But considering that security is a team sport and there are no bench warmers, how do organizations break down traditional team silos amongst networking, infrastructure, and app dev teams, shifting into hybrid teams as part of the Shift Everywhere role in SDLC? How do teams engage without understanding external teams' requirements, standards, and controls? Quite a heavy question we got, Chai.
Yeah, it's hard to address all of it, but what I'm going to do is I'm going to kind of address it at a very high level. And I touched on this a little bit. So the way, again, for say, if you're 1,000-person enterprise, right? If you have 1,000 developers, rather, a lot of times 1,000 developers only have 6 software security engineers. So it's impossible to scale, and especially if you're scaling up across the organization. So it's not just your 1,000 developers, but you're scaling across networking, you're scaling across infrastructure. You absolutely have to have security champions. So you have to make sure that you find people within those departments who are interested and inclined to learn more about software security. And then you have to train them, you have to nurture them to be your champion within those departments, right? So you're almost kind of expanding the role of software security and making sure that it's more appropriately followed in each department without adding people. So we have done a really good webinar on security champions. I'll be happy to send you the link to the recording for that webinar, and we talk exactly about this problem. It's a lot more detail on that, and we literally cover every part of this question. So I would urge you to please listen to that recording, and it's really interesting and educational. So.
Perfect. We've got a few more questions here. How does Shift Everywhere affect development velocity?
Yeah, that's a great question, right? So you're doing a lot of testing across the SDLC. You're doing it as often as possible and as frequently as possible. And at the same time, DevOps is wanting you to go as fast as possible and as frequent and release apps into production and software into production as frequently as possible. So obviously, the more testing you do, the more friction you generate for your development velocity. So again, having a tool a centralized tool for ASPM, application security process management, is really important, right? Because that way you're orchestrating your application security testing and you're doing testing at the right depth and at the right time. So you're not doing testing unnecessarily. Okay, only if something changes, you're testing it, or if something has differs from your original design, you're doing the test. So having an ASPM tool to orchestrate your testing really helps with that and helps manage your development velocity. Again, it also depends on the application security tools that you're using, because you can use some, fast scanning tools that actually scan much faster, have much lower false positives as well. So, if you have a tool that generates 2,000 false positives, you're going to spend a lot of time triaging those. It's a waste of time versus a good tool that you invest in and generates only, it has the right 10 vulnerabilities and defects that are really matter to you, and then you're triaging only what matters. So having, it's a dual approach here. Having an ASPM tool orchestrate the right testing at the right depth, and on top of it, making sure that your application security testing is the best of breed. So you are running fast testing and you're having really good solid test results. So that's kind of how you're approaching it.
Awesome. So we've gotten our first question in regards to AI. So how will AI impact application security?
Yeah, that's a great question. So thanks. And so when the latest version of BSIM came out, which is BSIM 14, AI was still relatively new. So we had not seen as much of it in leading software security programs yet. So I'm hoping that BSIM 15, which is due to come out in November of this year, will have a lot more on AI, because but AI is definitely there. There's a lot of LLMs being used, and I imagine, as with everything, AI is pulling in a lot of code from different open source libraries, and so there will be some inherited vulnerabilities, I'm guessing. So we'll see how that goes, but hopefully by November we'll have a lot more data on that. But I'm assuming as more AI generated code happens, you have to make sure that your AI generated code is defect free. It's coming from the right current open source libraries, and also manage licensing accordingly as well, because you could be using code which AI has pulled from an open source library, and you're not even aware of the licenses that are associated with it. So that's another thing to keep in mind. So we'll have a lot more of that in BSIM 15 for sure.
Awesome. We'll be looking forward to that. We are down to our final two questions at this point in time. So last call for any questions, if anyone has any. So jumping right into our second to last, can SBOM scans be automated? And if so, how?
Yeah, so again, I'm not an SBOM expert, but we have a webinar that we can point to you. So I would, if it's possible, we'd love to get you the webinar for SBOMs, and I'm sure will answer your question. So would it be possible to send them the link to the webinar, Cody?
Yes, it looks like we actually have Jenny who's on that right now.
Awesome, thank you.
Yeah, she's doing everything behind the scenes for us today. So it looks like we were on our last question. What do you recommend as steps we need to take to mature our software security program?
Yeah, that's a great question. So maturing your program, it all begins with knowing where you are currently. So you obviously have to take a look at what you're currently doing, what activities are you doing, what practices you're doing. Again, I would urge you to go to the BSIM website and download the BSIM report, download the framework, and you can implement the framework on your own. It gives you a way that you can measure your software security program right now by looking at what activities you're doing, what activities you could be doing. And it also gives you data from other companies, other peers in your industry. So if you're a healthcare company, you can look at other software security activities and practices that other healthcare companies are doing and compare them to your own. And then you can see what's missing. And then you can try to build in those activities into your program. So that's what I would recommend. Is the first step is download the BSIM framework, measure what you're doing, and then figure out where you need to go to mature your program, and then what activities you need to add to your program, and then create a roadmap that you can fill in these activities to kind of build your program where you need to be. So we'll send you the link for where you can download the BSIM framework. So that's a great place to get started.
Absolutely. So we have exhausted all of our questions, but one thing I do want to point out is that both of those webinars that Chai has mentioned or referred back to, Ginny has posted for us in the chats. If you're viewing this on demand, I will make sure that they are included in the handouts. So do check those out for some extra learning if you'd like to do that in those areas. So Chai, it has been an absolute pleasure speaking with you over the past hour. Before we bring things home, I did want to give you the opportunity to leave us with any parting words of wisdom, anything that you've got for us, we'll take.
Thanks, Cody, and thanks everyone for joining. And if you really appreciate it, hope you're shifting everywhere as well. And if you have any questions or need any help with Shift Everywhere, please contact me at any time. Thank you.
Wonderful. Chai, thank you so much. It has been such a pleasure having you on for the last hour.
Thanks, Cody. Have a great day, everyone.
All right. And so before I release everyone officially, just a couple of final notes. Today's session has been recorded, and we'll be sure to send you that recording via email here shortly. It'll also be available on the DevOps website. Just visit devops.com/webinars. If you look at the chat as well as in the handouts, you'll find a link to our post-webinar survey. And we would love to hear your feedback about our session today, or if you have any suggestions for future topics, please let us know there. We would love to hear your feedback. Filling that survey will also make you eligible for our $50 Amazon gift card giveaway. So I will be selecting 2 of our winners here shortly. So thank you all for your chats, your questions, and your survey responses. I'd like to thank Synopsys for sponsoring this program today, and to everyone in attendance, thank you so much for spending your time with us. We really appreciate you, and we hope to see you at a future Techstrong Learning Experience. Have a great rest of your day, and you may now disconnect. Thanks again, Chai.
Thanks.